Okay, so as we look at 5.2, we're going to keep talking about normal distributions. And here's where I think it makes a little more sense. When we're talking about finding area to the left of some value, you may be wondering, why do I care about the area? Well, think about it for a minute. We said we could use it as a percent. The whole thing is 100%. So if we had an area of 0.8975, that would mean that 89.75% of the data is below that point. In other words, I'd have an 89.75% chance of selecting something to the left of that value, and that might be more useful for me. So that would let me find the probability that X would fall into that interval, okay? So here's an example where this isn't a z-score, is it? I mean, what's my mean according to this graph? 500. What would be my standard deviation? 100. And then I'm asked to find the probability that X would be less than 600. So look at this. You still sketch the curve. You label all those pieces on there. And if I wanted to calculate that area to the left, the probability that X is less than 600, how do I do it? Do you want to change it to a z-score? I'll tell you this, if you want to use the table, you have to change it to a z-score. Okay, so let's see how we would change this thing into a z-score. Give me just a second. And where did I put those? Okay, well, I don't know where I set my extra handouts on the, oh, here they are. Okay. So let me do this. I think I messed that up on the last one. All right. So here's what I want to show you. I'm just going to put it at the bottom of this one. And our graph looked like this. The mean was 500. The standard deviation was 100. So if this was 600 and we wanted the probability that some X value would be less than 600, we want to change that to a z-score. So Z would equal, how would I calculate Z? Remember the formula is Z equals X minus mu over the standard deviation. So what do I put in for my X value? Where is the value that I want all my X's to be less than? 600. So X is 600 minus, what's the mean? 500. And then I'm supposed to divide that by what? 100. That's my standard deviation. Well, how much is 600 minus 500? And 100 divided by 100 is 1. So what I'm trying to find would be the probability that Z is less than 1. Now, if you go to your table and you want to look this up, make sure you're on the positive side. And 1.0 is what? 0.8413. Okay? If I want to use the table, I've got to change it to a z-score.
Where's the formula for the z-score?
It's at the end of chapter 2. Yeah, there's a formula there for Z. Okay, and then it's probably, no, they didn't. Yes, they also repeated it in chapter 5. So it's also written in chapter 5, but it's in both of those places. Now, let me show you why this is kind of nice, okay? I could calculate this and not have to change it to a z-score. Here's how. If I go back to normal CDF, this time, if I'm looking at my graph, okay, the problem is I'm not sure what this number ought to be. So remember, I can just put in something that's way far away, like a negative 100,000. That ought to have me covered. I'm way out in the tail there. My upper would be what? Where does the graph stop? At 600, right? But my mean is not 0 anymore. What was my mean on this original problem? 500. What was my standard deviation? 100. See, I don't have to convert it if I want to put it in here. And we just got points. Did I put that in right? What? Yeah, we should get the same thing. I must have typed in something wrong. Let me double check that. So I've got a negative there, upper 600, mean was 500, standard deviation is 100. That is so weird. I don't know why it didn't calculate it right the first time. But we did get 0.8413, which is the same thing we found in the table. Okay? Yeah.
Mine doesn't show up the lower and upper and the mean and all that. It just says the normal CDF.
In parentheses. So you've got to understand, you'll need to make notes somewhere if you want to put it in your calculator, that you've got to put your lower boundary, which is going to be furthest to the left first, comma. Then you put your upper boundary, comma. Then your mean, comma, and your standard deviation.
And then the close parentheses.
And then close parentheses.
Right.
Now, if we had wanted to go ahead and use the z-score but do it in the calculator, should we still get 0.8413? We should. So if we wanted to put a lower boundary of, in fact, I can still leave it what it is. I just need to make sure I'm way out in the tail there. But my upper, if you remember when we changed it to the z-score, that turned it into 1. So I'll put the upper at 1. But since it's a z-score, the mean would be 0. The standard deviation would be 1. And that's the same number, isn't it? So that what I'm telling you is the calculator will give you the ability to come up with the probabilities or the areas without having to change it to a z-score if you want. Where it's very useful is if you're getting the area between two values. Think about it. We're going to see one of these in a second. Because if they aren't already z-scores, I'd have to change both of them to z-scores, and then I would have to look both of those up in the table, and then I would have to subtract, and that's a lot of work. So here's what we found was that was 0.8413. Now this is an example here that we're going to do together. Survey indicates people use their cell phones an average of 1.5 years before buying a new one. Up until last year, I was the exception. I had kept the same phone for like 4.5 years. I've learned the hard way that's a very bad idea. You know why? Because one day it died completely, and I lost everything that was in it because they told me they could not recover it. So I'm not going to do that again. The standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability the user will use their current phone for less than a year before buying a new one, and assume that the variable X is normally distributed. Okay? So what I want to do is go back to the worksheet, and we'll work on this together. Now, what did we say is the first thing you should always do on these problems? So we're going to sketch the bell-shaped curve. How do I know it's supposed to be a bell-shaped curve? What did it say? It talks about a standard deviation but here's the key. It says assume the variable x is normally distributed. When you see normal distribution, that's when you know you've got a bell-shaped curve. Now, what information do I need to put on here? Do I know the mean?
Yes.
What is it? 1.5. Do I know the standard deviation? 0.25. And what is my x value I'm supposed to use? I want the probability that the user will use their current phone for less than 1 year, that x is less than 1, right? Now, at this point, make sure you recognize the difference between whether you're working with x values or you're working with z values. Should this be x or should it be z? As far as this 1 that they gave me. It's x, because if it were z, what would the mean have to be? 0. And the standard deviation would have to be 1. These are not. So that's what tells me that's an x value. Okay? Now, if x is supposed to, I want the probability x is less than 1 and the mean is at 1.5, is 1 going to be to the right or to the left of the mean? To the left. So somewhere over here is a value of 1, and we're trying to get the probability somebody would keep that phone less than 1 year. Now, if I were to take a quick vote, how many of you say, I'd rather do the z-score, go look in the table? How many of you say, I'd rather do this in the calculator? How many of you say, I can't even tell what I'd want to do. I'm still trying to figure out what class I'm in. Okay, so if you want to change it to a z-score, z equals, what's that formula? X minus the mean divided by standard deviation. Now, those of you who say, I want to do the calculator, if you think you know how to get the answer, you go for it. Well, I'm helping those who want to get the z-score first. So tell me what you put in for x. 1 minus, what's your mean? 1.5. And your standard deviation was 0.25. Okay, crunch those numbers in your calculator. Let's see what you get. So I have 1 minus 1.5, and I'm going to divide that by 0.25.
I have -2.
Yeah, I must have, hang on a second. Let me do this. 1 minus 1.5. I need to put that in parentheses and then divide it by 0.25. I confused the calculator on order of operations, so I need to fix that. If I've got a fraction, I need to make sure I put everything in the numerator in parentheses before I divide. So that is a good lesson for us to see. You can get the wrong value if you don't put it in where the calculator understands what you want. Beg your pardon?
Oh, you're doing something.
Okay, we're just getting the z-score. So if we change this to a z-score, then we're trying to find the probability that z is less than -2. Now, at that point, you can go look it up out of the table if you want. If you wanted to do it in the calculator, you can, and use the z values. How many of you went to the calculator and you used this mean and this standard deviation and you used 1 for your x value and you think you found the area? Anybody? Okay, a few of you. How many of you took the z-score and you want to go to the calculator and figure it out? You can do it either way. That's totally up to you. If you're looking at the table, the probability that z is less than -2, I got to be sure I'm on the side that has negative numbers. And what is the z-score that is -2? 0.0228. If I did it in the calculator and I did second bars and I choose normal CDF, then I could leave that because I'm in the tail on the left side. Okay, so I could leave that number, but I'd put in an upper value of -2 with a mean of 0 and a standard deviation of 1. And there's 0.0228 when I round to the nearest 10,000th. Okay, and if you had wanted to type in this way, where you said this is your lower boundary, but I'm going to put in an upper boundary of 1 because that was my x value. And I put in 1 point, what was that, 5 for my mean, and I put in 0.25 for my standard deviation. I still get the same thing. So there's 3 different ways that you could calculate this probability, and you pick whichever one you're more comfortable with, okay?
I did it differently, and I still got the same answer.
What'd you do?
I did the lower is -2 and the upper is 1, and then 1.5 and 0.25. I still got the exact same answer. So I kind of confused myself.
Yeah, that would confuse you. That's very much a coincidence. Yeah, you want to make sure, because you kind of mixed and matched a little bit between Z's and X's. Yeah.
But then I got confused because I got the same answer.
Yeah, that's just a really random coincidence. Okay, not that that makes you feel better.
What'd you use for one?
I mixed it in. I guess I put like the -2 is the lower, and then 1 is the upper, and then the mean is the standard deviation is the same.
Could you use 1.5?
Yeah, that's just a random coincidence. So 0.0228 is the correct answer, although don't use Destiny's method. Most of the time that's not going to work. All right, here's another one. A survey indicates for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store is normally distributed and is represented by the variable X. The shopper enters the store. Can you find the probability that the shopper would be in the store for between 24 and 54 minutes? What do you say? All right, so I'm going to turn the page because we have this on here. What would be the first thing we would want to do? Draw the bell curve. Why am I going to be able to use the bell curve? What told me I could? There you go. Normally distributed. That's very important. If I don't see it, I can't assume it. So, normal distribution. What was the mean? 45. What was the standard deviation? 12 minutes. Okay. Now, what is my question asking me to find? Yeah, the probability that a shopper would be in the store between 24 and 54 minutes. Now, 24 would be on which side of the mean? Somewhere over here on the left. 54 would be on the right side. So I'm wanting the probability of this area. That's going to give me the likelihood that some shopper would be there somewhere between 24 and 54 minutes. Now, are these z-scores or are these x values? X values. If I want to use the table, I got to do what with them? And I got 2 numbers that have to be changed to z-scores. I'd have to look both of them up and I would have to subtract. Perfectly okay. It's just a lot more work. Do you see where this is an advantage in the calculator? Oh yeah, because if I go to the calculator, tell me what buttons you would press. Second bars, choose, number 2, and this time what goes in for lower? Yeah, because that's where the shading starts. What goes in for upper? 54, and the mean is 45, and the standard deviation is 12. And I've got 0.73331, da, 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 da. So if I go 4 places to the right, would y'all agree that's 0.7333? That did not take very long by doing it in the calculator. If we go back and look at the PowerPoint, I want you to see if we get the same answer, because this is all the work involved changing it to z-scores. You got to change this one to a z-score. You got to change this one to a z-score. You got to look up both of these in the table and subtract. 0.733. We did it. but we did it faster than it would take doing this all by hand. Okay, we good? Now, here's another variation of this question. If 200 shoppers enter the store, how many shoppers would you expect to be in the store between 24 and 54 minutes? You've got it, Lindsay. Did y'all hear what she said? She said, if I know the probability that a shopper would be there between 24 and 54 minutes is 0.73333, I just have to multiply that times 200, and that'll tell me how many shoppers. Does that make sense? Well, you just want to type in the 0.7333. You don't want to keep the extra digits on this one and multiply it times 200. Yeah, and that would give you 146.66. Now, because we're talking about people, I would round to the nearest whole number. I don't want to see 2/3 of a person come in my store. That would be a little freaky. So about 147 shoppers. Okay. Same basic information, but now we're going to tweak it a bit to where we want to find the probability that the shopper would be in the store for more than 39 minutes. Now, is that actually a different graph? It is. So what I want to do is take us back to the notes, and we better sketch the graph again. Did the mean change? No, nor did the standard deviation. But I want to know the probability that a shopper would be there more than 39 minutes. Now, 39 is to the right or the left of 45. Left. And if I want the probability they're there more than 39 minutes, which way do I shade? To the right. Now, if you want to make it a z-score, you can do that. Look up that value in the table, but you better be sure you do what after you get that value out of the table? You got to subtract it from 1 because we're working with a right-hand shade. So let's see if we could do this without changing it to a z-score. If we go into second vars and we choose normal CDF, what would be my lower boundary for this situation? 39. That's the one furthest to the left. Now for the upper, this is again where I just want to put in a really big number. So maybe 100,000 or 1 million, something like that. My mean is still going to be 45. Standard deviation is still 12. That looks like rounded to 4 places, I get 0.6915. Okay. Now let's see what happens.
I have a question real quick.
Yes.
So I just jumped ahead and I still use the lower as like 100,000 and I use 39 as the upper, and then I subtracted what from 1.
Okay, yeah, if you do it that way, then the area you get, you would have to subtract from 1.
Okay.
Okay, because that would be the equivalent of reading it out of the table. You're getting the area to the left if you do it that way. So here's what it would look like if you wanted to use the table. That's our diagram, which looks like the one we did. But then they converted this to a z-score. 39 minus 45 divided by 12 gives us negative 0.5. So we want the probability that z is greater than negative 0.5. If you look it up in the table, 0.3085 is the area to the left. When you subtract it from 1, you get 0.6915, which is what we got, okay? Now, if 200 shoppers enter the store, how many would you expect to be in the store more than 39 minutes? All you have to do is what? Multiply 0.6915 times what? That's it. And that would be about 138 shoppers. We'll round down a little bit on this one since it's just barely over 130. I'm sorry, what? On this question, if it is using the information you just found, no, you wouldn't have to. Because on the previous question, yes, I want you to sketch it. Okay? Now, this is simply explaining what I just showed you, how you can use the calculator. So let's see if you guys could take this and figure out how to put everything in the calculator yourself. Anybody have issues with triglycerides? Not to put you on the spot. As we get older, unfortunately, we tend to, it's kind of like, you know, if you live in an older house, over the years, you get stuff that clogs up in your pipes, and every now and then you have to get them cleaned out. So that happens in your bloodstream as well. Triglycerides are a type of fat in the bloodstream. The mean triglyceride level in the U.S. is 134 milligrams per deciliter. Assume that the triglyceride levels of the population of the United States are normally distributed with a standard deviation of 35 milligrams per deciliter. You randomly select a person from the U.S. What's the probability the person's triglyceride level is less than 80? And it tells you to use a technology tool to find the probability. So in other words, see if you can do it without using the table. If you want to use the table, that's fine. This is just explaining how you would do it if you wanted to use the calculator. Now, is it something that the table would be valid to use? What words clue me in that I can either do a normal CDF or use the table? Normal distribution, very important. Okay, so let's see if you guys can calculate. That's what your bell curve should look like. I'll give you that much. How many of you have an answer? I'm just curious. Okay. Okay. So what did you come up with? Any brave soul want to share?
0.0614.
0.30.
0.0614.
Oh, 0.0614. Anybody else get that? Okay, it's not 100%. Let's see if 0.0614. Now, that would mean when you put this in your calculator, if you went to normal CDF, you could put in something like negative 10,000 or negative 100,000 or negative 1 million for your lower boundary. Excuse me, that's because we're out in the tail. You're going to put in 80 for the upper boundary. Here's your mean, here's your standard deviation. And so you should get 0.0614. How are we doing? Okay, we're going to keep practicing. Hopefully we'll get this all worked out before you guys leave. 5.3 is kind of more of the same, except we're going to go at it from the other direction. So what's going to happen is, instead of giving you a z-score and asking you to find area, I'm going to give you an area and ask you to find a z-score. Okay? Ooh, that'll be fun, won't it? So here's what it looks like since we're going the opposite direction. We're going to take the probability or the area and then backtrack to figure out what the z-score is. And sometimes we may even go back and find what the x value is that would go with it. So if we need to find the z-score that would correspond to a cumulative area of 0.3632, if I'm using the table, how do you think I would go about doing that? Where would I look for 0.3632? I got to look in this part of the table, not the outer columns and rows, and I'm going to have to find where it's 0.3632. Now, should that be on the positive side or the negative side? Negative side, and I know that because that's a number that's less than 0.5. So I'm going to scan through this, and I'm going to see if I can find 0.3632, okay? So notice what we've got. I'm looking at these are 0.2s, 0.3s. My 0.4s start here. So I've got to check through here. Do you see 0.3632? It's right there. So what is the z-score that goes with that? Negative 0.35. Right? Okay. That's exactly how you read it. You would find it in the table, and then you would look for where it goes. Now, do you recognize an issue we might run into here? What if the area I asked you to find was 0.3614? It's not in the table, is it? So what we would have to do in that case, and we're going to talk about this in just a second, would be, I know it falls between here and here. And then I'll just go with whichever one it's closest to. Basically is what I would have to do if it's not in there exactly. Okay? Now, if this says find the z-score that has 10.75% of the distribution's area to its right, tell me how you think we could go about finding that.
Subtract 25. Or subtract 136.
Okay, well, let's see. Okay, I've got it on here. Let me pull this up real fast. Okay. I would sketch the graph. Okay. And if it's 10.75% of the area to the right, then that's going to be, what is a decimal number? 0.1075. Does that sound like that's very much or that's kind of small? 0.1075 is kind of small, but it's to the right. So somewhere in here, I've got an area that's 0.1075. Does that part make sense? Okay. Now, if I go to look in the table and I look at 0.1075, I'm looking on which side? I'm looking on the negative side. So if you look at 0.1075, that looks like it's a negative 1.24. But I know this needs to be a positive number, correct? Okay, so let me give you a heads up. Is this symmetric about the mean? In other words, everything on the left side is a mirror image of what's on the right, correct? So if this was a negative, what did we say it was? 1.24? And that has 0.1075 of the area in it. What do you think this z-score would need to be? Positive 1.24. You can use the table, and that's a nice little shortcut if you know it. The other thing you could have done is you could have taken 1 minus 0.1075, which would have given you what? 0.8925. And then if I looked at 0.8925 in the table, 0.8925, that would have been the positive 1.24. So we just confirmed that it works. So you could go either way on that. If you draw the diagram and you decide, even though this area is to the right, I'm going to look up this number in the table. You just need to remember it's going to be the opposite sign of what came out of the table. Does that make sense? If you want to go ahead and do 1 minus that area, you could look up this number in the table and it will be the actual z value you're going to find. So far, does that make sense? Okay. So there's our diagram. This is explaining, subtract that from 1, look up the 0.8925 in the table, and you're going to find 1.24. If we wanted to find a z-score given a percentile, okay? A percentile means out of how many? Like if you scored in the 89th percentile on the SAT test, then that means that you scored better than 89 people out of 100. All right, percentiles are always in hundreds. So if I want to find the z-score that corresponds to the P sub 5, and by the way, there won't be any of these on the test, you just might see 1 or 2 in the homework. What that's telling us is we want the same z-score that would have an area of 0.05, because 5% would be the same as 0.05 as a decimal, okay? So that's what you would look up in the table. And this is one that if you look in the table, you're going to see that 0.05 is not there. All right, so let me just show you real quickly. If we wanted to find 0.05 in the table, it probably would be helpful if you did that, but if you understand what it means when it says find the z-score that would go with a percentile of 5, that means an area of 0.05 because it's always going to be to the left. So here's what I'm noticing. I've got 0.0495 and I've got 0.0505. I don't have 0.05 in here, but is it exactly halfway between those? Then that means I would have a negative 1.65, let's see, between 0.05 and 0.04, it'd be a negative 1.645 because 0.045 is in between, or yeah, it would be in between 0.04 and 0.05. Now, let me show you something. We're going to be working with these pretty soon. And you see that 1.645 right here. That's going to be a common value that we use if we've got 5% in a tail, okay? But what I just want you to see, if you're using the table, you got to go halfway between. Now, let me go ahead and just show you. If we were trying to get the z-score, actually that one's not on here. So we were trying to get it that goes with the percentile of 5. If I want to use the calculator on any of these where I know the area and I want to get the z-score, here's how you do it. Go back into second bars, but instead of normal CDF, do you see what number 3 is?
Inverse.
Inverse norm. What does it mean if you do the inverse of something? Opposite. It's like when it's backwards. That's what we want. So we're going to choose 3. And this is when I know the area and I want the z-score. So if my area is 0.05 with a mean of 0 and a standard deviation of 1 because I'm trying to get a z-score, look what it gives me, negative 1.64485. If I round it 3 places, it becomes negative 1.645. So you may find it easier to do inverse norm than using the table when they give you the area and ask you to find the z-score. Does that make sense?
So the numbers just off a little bit.
Well, if you round 3 places, then you got it, negative 1.645. Okay? So just as a quick reminder of what we've done so far in chapter 5, if I give you a z-score and I ask you to find the area to the left of the z-score, how do you do it? How many of you say, I'm going to look on the table? And that's fine. How many of you say, I'm using the calculator? So if I'm using the calculator, where do I go?
Second bars.
Second bars, choose
Option 2.
option 2, which is normal CDF. And then what do you put in first? Lower boundary. That's got to be the left-hand part of the shading. Then you put in the upper boundary, which will be the right hand where at the end of the shading. And then you've got to type in the mean and the standard deviation. If it's looking for a z-score, mean's always 0, standard deviation is always 1. It's only if we're using x values that we have to change those. And then you can get those areas from there. If I'm looking for an area, it needs to match how many decimal places there are in the table. So that means I always round that how many to the right? 4. So if I'm looking for an area, I got to round that 4 places to the right. Okay? If I am given the area and I'm trying to find the z-score, I can either look in the guts of the table and try to find the z-score that went with that area, or if I go to the calculator, where do I go to get it? Second bars and choose inverse norm. And all I have to type in is the area and then tell it what the mean and the standard deviation is. As long as I'm looking for the z-score that goes with that area, the mean is 0, the standard deviation is 1. Okay? All righty. Let's go back. And this would give us the ability to take a z-score and change it back to an x value. So if we found the z-score from looking at the area in the table, but then they told us that we needed to get the x value that belongs to it when the mean is such and such and the standard deviation is such and such, we could plug into this formula. So let me give you an example here. A vet records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds, standard deviation of 2 pounds. So you want to find the weights, which would be x values, that correspond to z-scores of 1.96, negative 0.44, and 0. So do you understand what that's asking you to do? All right, let's look at it and make sure we get to the point that this makes sense. So here's what we have. The weights are normally distributed. Is that important? Yes, that's what tells me that I get to use this normal distribution and I can work with z-scores and so forth. Now the mean is 9 pounds. The standard deviation is 2 pounds. And I want to get the x value for the weights that would correspond to these z-scores. So the formula that I have was x equals, and if you look on your formula sheet, we actually had it back in chapter, well, here it is in chapter 5. X is equal to the mean plus the z-score times the standard deviation. So x is equal to the mean plus the z-score times the standard deviation. That's just a variation of the z equals x minus the mean divided by the standard deviation. So here's what I would do. I'm going to put in my mean, which is 9, plus, if I want to use a z-score of 1.96 and multiply it times my standard deviation of 2, what's that going to give me for a weight? 12.12? 12.92. Let's try using a negative 0.44. So that's 9 plus, and I'll put in negative 0.44 times 2. What would that be? 8.12. What happens if my z-score is 0? It's just 9, because I'd have 9 plus 0 times anything is 0, and 9 plus 0 is 9. And these are all in pounds, right? Okay. Does that make sense? As long as you have that formula, that's pretty easy. Agreed? Agreed. Okay.
Then we don't have to just get those.
Yeah, you're just changing them back to X values, and we got all those right. All right. Now, this is going to be our last example. Scores for the California Peace Officer Standards and Training Tests are normally distributed. The mean is 50, standard deviation is 10. The agency will only hire applicants that score in the top 10%. Have you guys ever had to do like a test where, you know, they're only going to take if you get a certain score? Probably. I know my son and my son-in-law are both firefighters. And so when they opened up the testing window this last time for promotions, they would not let anybody promote unless they had a minimum score. You had to have at least this much. And part of that is keeping it to a certain percentage. So sometimes that happens. Now, you're supposed to figure out what the lowest score you can earn and still be eligible to be hired by the agency, what that would be. Okay? So you think we can do that? You're supposed to say yes. All right, let's do it. So, first of all, tell me if you see the keyword we need to know if I can use bell curve here. And do you see that? Yes, it's right there. Awesome. So I'm going to sketch a little curve here. And tell me the information that I know. Mean is 50. Standard deviation is 10. An agency will only hire applicants with scores in the top 10%. So if my scores are in the top 10%, does that mean I'm looking for something that's in the right tail or something in the left tail? Right tail. Top 10%, that's when I have an area that's 0.10, correct? So I've got to figure out the lowest score you can earn and still be eligible to be hired by the agency. All right, how would you want to do that? The one on the problem just before this one? Okay, we could use this formula, but to use it, I have to know the mean, I have to know the standard deviation, but I also have to know the z-score. Do I know the z-score? No. So how would I go about finding that? Say it again. No, that won't give me the z-score. I need to know what this value is if this area is 10%. 1 minus 0.1. Okay, if I do 1 minus 0.1, I get 0.9. That's going to be all the area to the left, which means I could look on the table, see if I find an area of 0.90, and it's not in here exactly, but which one of these numbers is closest to it? Yeah, which one is closest to 0.90? 1.29, because 0.8997 is closer than 0.9015. Does that make sense? So if you're using the table, that's what it's going to tell you to do, is to pick the one that it's closest to, unless it's right in the middle. If it's right in the middle, then you can go out 3 places. Okay? So we're going to use 1.28 for a z-score. So if I want to change this back into an x value, then I'm going to have to take the mean plus z times my standard deviation. My mean is 50. My z-score was 1.28. And my standard deviation was 10. All right, so what are you guys coming up with? Say it again. She says 62.8. Does anybody else agree with that? Okay. So I want us to try something. Okay, well, let me ask you this. Do you think we could use inverse norm? Okay, because inverse norm gives us a value when we know the area. So if I go into inverse norm, now, you know how she did 1 minus 0.1 because it did area to the left. Because the calculator is also going to do area to the left. Is it okay with you to put in 0.9? But notice what else I can do in the calculator. What did this problem tell me is the mean? 50. What's the standard deviation? It'll give you the x-score where you don't have to use the formula. Because that's the same thing we got, right? 62.8. Does that make sense? That's the beauty of the calculator, where it will let you make those adjustments. Now, let's double check. Since we got a z-score of 1.28 the first time we did it, and we plugged in, we got 62.8. We did it using inverse norm, and we still got 62.8. So you would need a score of about 63 in order to be eligible to be hired. And that is it.